So rational equations are equations that look like this. You know, if you have y equals 3 over 2 minus x. And so a rational expression would be just something that's not an equation, right? So 3 over 2 minus x is a rational expression. So rational expressions are things where we got, usually we're talking about it algebraically, we got a variable and we have some sort of fraction going on. An important thing to note about rational expressions is sometimes there's values we have to omit from the equation. Like if you look at this rational expression over here, x cannot equal 2. Because if we were to plug in 2, we'd have 3 divided by 0, which is undefined, right? 0 fits into 3 an infinite amount of times, an undefined amount. Nothing fits into 3, there's no number for that expression. Okay, so what we do with rational expressions is we can use them to help us make equations to model some real-world situations. Oftentimes we need to factor them though, okay? So if we have like this equation, this is going to be a rational expression. If we have this rational expression, the numerator is something we've typically seen before at this point in an algebra course. X squared minus 3x plus 2, that can be factored to x minus 2 and x minus 1. And a quick recap of how I did that was I found two numbers that multiply to be positive 2. Negative 2 times negative 1 makes positive 2. And they need to add up to be this middle term. Negative 2 plus negative 1, that makes negative 3. So I factored this rational expression, and when I've done that, I see I actually have two things that are the same in the numerator and denominator. X minus 1 divided by x minus 1 just makes 1. So the rational expression I had over here simplifies to be just x minus 2. So we do that a lot with rational expressions. Let's see what else we might see. Something like this. What you want to do is, again, try to factor to see what the biggest thing is you can pull out of things. Find the, let's try to factor the numerator here. We can factor out a 2 from both the 6x squared and the 2x. And we can also take an x out of both those, right? This has 2 x's to give because it's a power of 2. This has just 1 x. Now look over here. That's not nothing, right? Because we pulled out a 2x. What you're doing is you're dividing 2x out of everything over here. So 6x squared divided by 2x makes 3x. 2x divided by 2x, it doesn't make nothing because it's not subtraction, right? It leaves us with 1. We still have over 4x in the bottom. And by factoring, we found out we could reduce, right? The x's can cancel. And we got 2 over 4. Those are both divisible by 2, so let's say 2 for the bottom part. This is our simplified answer because I divide the top by 2 and the bottom by 2. A fair move because I did the same to the top and the bottom. I kept it balanced. And now that there's nothing in front of that parentheses, I can just drop the parentheses. Okay, so that's one thing you might do when you simplify rational equations or rational expressions. I've been doing just expressions here. Let's see, one more thing before we finish up this video. What if we had two monomials for a rational expression? So the numerator has 2 x's, the denominator has 3 x's, so we're left with 1 x in the bottom when we subtract those x's out from each other. They cancel out with each other, right? X squared and the x to the third. When you take out 2 x's, you're left with x to the first power. We got 1 y up top, we got 4 y's on bottom, so once we subtract those and make them cancel out, we have 3 y's on bottom. And then to simplify a little bit further, divide the top and the bottom by 7. So that's another type of rational expression you're going to be simplifying. Okay, I think that's it. Let's make another video for when we multiply, divide, add, and subtract rational expressions.